So in this problem, it has been given that a block is resting on a surface, rough surface, coefficient of friction is 0.5, the mass of the block is 10 kg, and the force is acting on the block with an angle of 37 degrees with horizontal. Now the question is whether the block would slide on the ground or the block will be lifted up. Which one will happen first? Supposingly that the force, the value of the force starts from 0 and keeps on increasing. So first, what would happen? Whether it would slide on the ground or it would be lifted up. So that's the problem, and shouldn't take more than 2 minutes for you to solve it. The answer is it would be slipping on the ground first before getting lifted. And so how we would do it? Suppose the force acting is F. We'll calculate the minimum force for both, for lifting and for dragging, and we'll see which one is going to happen first, depending upon whose value is less. Now, the minimum force required to lift the block up, that would be the upward force. The external upward force is F sine 37 degree. And sine 37 degree is 3 by 5. So 3 by 5 F would be acting upward, and the downward force would be mg. Because at the point when it is at the verge of getting lifted, then there is no normal reaction. There is no contact. Normal reaction is because the block presses the ground. When it is about to get lifted, then it is not pressing the ground. Normal reaction at the point, just at the moment when the block is going to get lifted, then the normal reaction at that very point will vanish. It will become 0. So at the verge of getting lifted, the only external force in upward direction is 3 by 5 F, and in downward direction is 100. So minimum amount of force required would be 500 upon 3. That's the minimum amount of force for lifting. Now, if the block is to be dragged, then the force that's going to do that is horizontal component of the applied force, F cos 37 degree. That is 4 by 5 F, and it should overcome the friction force, because that's only opposing force in the horizontal direction. Friction force is mu times normal reaction, and normal reaction would be mg minus vertical component of this force. That is 3 by 5 of F. Now mu is given as half. So from here you would get F as 8 by 5 F and 3 by 5 F. 11 by 5 F is equal to 100. You will get F as 500 upon 11, and you can see which one is less. This one seems to be less. So this thing is going to happen first. The slipping of the block on the ground is going to happen first. So if you keep on increasing the value of force, then what would happen is slipping will occur first before the block getting lifted up. Okay. Okay. Then now in this problem we have a block, and the block is kept on a rough surface. Suppose the coefficient of friction is given as mu, the mass is given as m. Now it has been, and if you take the acceleration due to gravity as g. Now it has been asked, what is the minimum amount of force that would be applied on this block to slide the block on the ground? It's a horizontal surface, the coefficient of friction is mu. What is the minimum amount of force that should be applied on this block so that the block moves on the surface? You have to find that in terms of the given parameters. Okay, let's discuss this. Now the force, you can take the force at any angle. It should not necessarily, shouldn't necessarily be horizontal force. The force could be applied at any angle. So I'll give you the answer and then we'll have a discussion. The answer would be the minimum amount of force required would be equal to mu mg upon root over 1 plus mu square. This is the minimum force. See, if you're going to apply only horizontal force, then what would happen is if you want to orient your force horizontally, then this force, the minimum amount of horizontal force will be mu mg, because it has to overcome friction force. Friction force is mu times normal reaction, mu times mg. Now as you can see, this is going to be less than mu mg because denominator is greater than 1. So the minimum amount of force will not come out in a case when you are applying the force horizontally. So in order to consider a general case, let's consider that the force is being acted at an angle theta with horizontal. If that has to be horizontal force, theta would come out as 0. So, but this is how in general you should consider the orientation of force. So the F is acting at an angle theta. You would have no problem if you fix this angle theta. If you consider that this angle theta is fixed, then you will have no problem in finding the minimum force at this angle theta at which the block will start to move. So minimum force at given angle theta would be mu mg upon it will be mu mg upon cos theta plus mu times sin theta, as we have done before. So we have found this expression before. Now what you have to do is, this is a function of theta. So as theta would change, so would be the minimum amount of applied force. So what we have to do is, we have to minimize this function which is dependent on theta. So if we have to find the minimum value of force, we should find the maximum value of this expression. If we maximize the denominator, then the whole fraction would be minimized. So let's do that. Now we know how to find the maximum value of a given expression, polynomial or trigonometric. We differentiate that. So the differentiation of this, differentiation of cos theta is minus sin theta, and sin theta is cos theta. Mu will remain as it is. If we equate this to be 0, we find that theta at which the maximum or minimum value will occur. In this case, it will be maximum value. Now, if theta is tan inverse mu or mu is tan theta, then that is the point at which you're going to get the maximum value of this expression. Now, when you do that, so at this tan theta should be equal to mu. Now if we replace whatever theta we have found from here, if we put that value of theta here, we'll get the minimum value of this expression. So this kind of thing we have done in maximum minimum when we started from calculus. This shouldn't be a problem. Now tan theta is perpendicular upon base, so we can treat mu as perpendicular and base as 1. So this expression would come out as mu times mg upon cos theta. Cos theta is base upon hypotenuse, so that will be 1 upon root over hypotenuse will be 1 squared plus mu squared, root over 1 squared plus mu squared, and sin theta is perpendicular upon base. So sin theta could be considered as mu upon root over 1 plus mu square. Okay, so from here we can see that the expression of force is going to come out as you'll get this. Okay, so that is the minimum force that will move the block. So the minimum force you'll not get minimum force when you're applying the force horizontally, rather you'll get minimum force when you're applying the force at an angle theta, which is equal to, tell me, which is equal to the angle of repose or the angle of friction with the horizontal.